Hello students. So we have completed up to question number 16, level 2, that is worksheet 3. Now we will start from question 17, that is comprehension type, page number 37, worksheet 3. Okay. Now 17th question. It is a comprehension type question. If cos alpha is given as 3 by 5, cos alpha is 3 by 5 and cos beta is given as 5 by 13, where alpha and beta are given as acute angles, means they are less than 90 degree. Okay, cos alpha is given as 3 by 5, cos beta is given as 5 by 13 and alpha and beta are acute angles, means they are less than 90 degree. Okay. Now, in less than 90 degree means they are in first quadrant. Now, cos alpha is given, cos beta is given. So, we will calculate first sin alpha and sin beta. Okay. For 17, 18 and 19 question it will be needed. Okay. So, we will first calculate sin alpha. So, if I draw a triangle for this, it will be a right angle triangle. This will be our alpha. Okay. Cos alpha. What is cos? Cos alpha is adjacent upon hypotenuse. So, its adjacent side will be this one and its hypotenuse is this one, that is 5. Adjacent upon hypotenuse is cos alpha, that is 3 by 5. Okay. So, by Pythagoras theorem we can calculate this side. So, it will be 5 square, that is 25 minus 9 under root of this. So, it will be 25 minus 9 is 16. So, under of this root of 16 is plus minus of 4. Okay. So, we will consider length is always positive. So, it will be 4. Okay. Now, what is sin alpha? Formula for ratio for sin is opposite upon hypotenuse, opposite upon hypotenuse. So, opposite side of alpha is this one, that is 4 and hypotenuse is 5. So, it will be 5. So, sin alpha we got as 4 by 5. Now, for cos beta, for calculating sin beta, we will again draw a triangle. Okay, this is a right angle triangle, this is, I take it as beta. Okay. Now, again cos beta, for ratio for cos is adjacent upon hypotenuse. So, adjacent side of beta is this one. So, it will be 5 and hypotenuse is 13. Okay. So, we have to calculate this side. So, what it will be 13 square minus 5 square under root of, by Pythagoras theorem it will be 13 square minus 5 square, it will be under root of 169 minus 25. So, it will be under root of 144, it will be plus minus 12. But here it is length, so we will take only positive, so it will be 12. Okay. Now, from this we can calculate sin beta. What is formula ratio for sin beta? It is opposite upon hypotenuse. So, opposite side of beta is 12 and hypotenuse is 13. Okay. So, we have got sin alpha as 4 by 5 and sin beta we got 12 by 13. Okay. I write the values. Sin alpha we have got as 4 by 5 and sin beta we have calculated as 12 by 13. Now first questions, that is question 17, cos square alpha plus beta by 2. We have to calculate it, cos square alpha plus beta by 2. Okay. Now, if we consider alpha plus beta as 1, that is A, if we consider this as one angle, alpha plus beta, if we consider it as A. So, what is the formula for cos square A by 2? Formula for cos square A by 2 is 1 plus cos A upon 2. Okay. Okay. Cos square A by 2 is 1 plus cos A upon 2. If we consider alpha plus beta as A, so we can write it in that formula. It is cos square A by 2 if we consider alpha plus beta as A. So it will be 1 plus cos A, 1 plus cos A. A here is alpha plus beta. So we will write alpha plus beta by 2. Okay. From this formula we have written like that, 1 plus cos A, our A is alpha plus beta by 2. Okay. Now if this is considered as A and this as B, cos of A plus B. Do you remember the formula for cos of A plus B? What was the formula for cos of A plus B? It was cos A cos B minus sin A sin B. We have written all the formulas in the previous lectures. Okay. See and revise it. Cos of A plus B is cos A cos B minus sin A sin B. So if we consider it as A and this as B, cos of A plus B. So we can write it in this form. So it will be 1 plus, now it is cos of A plus B, cos A cos B. So we will write cos alpha cos beta minus sin A sin B, means sin alpha sin beta. Okay. So it will be upon 2. So we have written cos alpha plus beta, that is cos of A plus B in this form, cos A cos B minus sin A sin B. Now we will put in the values. We have just calculated cos alpha was already given, so we will put it 3 by 5. Now cos beta, it is multiplication, so we put in the bracket. Cos alpha is 3 by 5, cos beta was given 5 by 13 minus. Now again sin alpha we have calculated as 4 by 5 and sin beta is 12 by 13 upon 2. Okay. Now here 3 by 5 multiplied by 5 by 13, 5 will get cancelled. So it will be 1 plus 3 by 13 minus 12 4s are 48 and 35, 13 5s are 65. So it will be 48 upon 65 upon 2. Okay. So I rub this. Now we have got equation as 1 plus 3 by 13 minus 48 by 65 upon 2. We have just put in the values of sin alpha, sin beta, cos alpha. Okay. Now if I take the LCM of this 13 and 65, it will be 65. So it will be 65 plus 15 plus minus 48 upon 2. Okay. It is upon 65 upon 2. Okay. Denominator we have taken the LCM as 65. So 65 plus 15 is 80. 80 minus 48. It is it is 32 upon 65. Now here it is upon 2, we can write it as 1 by 2. Okay. So it will be 2 1s are 2, 2 16s are 32. So our answer is 16 upon 65. Okay. So we have got the answer for cos square alpha plus beta by 2 as 16 by 65. So the option is third one. Okay. Now 18th question, sin square alpha plus beta by 2. Okay, sin square alpha plus beta by 2. So here again we can put the formula. Cos square a by 2 was 1 plus cos a by 2. So what is sin square a by 2? Sin square a by 2 is 1 minus cos a by 2. Okay. Here it is alpha plus beta. If I take alpha plus beta as a, we can consider it as sin square a by 2. So we can put it this formula here, 1 minus cos a by 2. So it will be 1 minus cos of a. A here is alpha plus beta by 2. Okay. Now again this formula is used. Cos of alpha plus beta means we can consider it as cos of a plus b. Okay. So cos of a plus b is cos a cos b minus sin a sin b. So it will be 1 minus cos a cos alpha cos beta minus sin alpha sin beta upon 2. Okay, we have just put in the formula of cos of a plus b. Now again we will put in the values of cos alpha, cos beta, sin beta. So cos alpha was given 3 by 5 multiplied by cos beta is 5 by 13 minus sin alpha is 4 by 5 and sin beta is 12 by 13 and this is upon 2. So it will be 5 again will get cancelled and it will be 1 minus 3 by 13 So here it is bracket. Okay, this is one term only. We have just expanded this cos alpha plus beta, so it will be in bracket because this here it is minus. So if I multiply minus inside the bracket, it will be minus and here it will be plus. Okay, this is one term, so we have put it in the bracket. So minus and minus will get plus. So 1 minus 3 by 13 plus 48 by 65 again upon 2. Okay. Now again if we take LCM, it will be 65. So it will be 65 minus 15 plus 48 upon 65. I can write upon 2 as 1 by 2. So it will be into 1 by 2. So again by solving, 65 minus 15 is 50, 50 plus 48 is 98, 98 upon 65 into 1 by 2. So it will be 2 ones are 2, 2 49s are 98. So our answer will be 49 upon 65. So for sin square alpha plus beta by 2, our answer is 49 by 65. So option is second one. Okay. Now tan square alpha plus beta by 2. Tan square alpha plus beta by 2. Okay. Now for tan square a by 2, what is the formula? Tan square a by 2 is 1 minus cos a upon 1 plus cos a. Okay. Now formula for tan square a by 2 is 1 minus cos a upon 1 plus cos a. If we consider this alpha plus beta as a, we can put that formula in this. Okay. So if I tan square a by 2, that is alpha plus beta by 2, so it will be 1 minus cos a. Here our a is alpha plus beta upon 1 plus cos of alpha plus beta. Our a is alpha plus beta again. So we have calculated this value 1 minus, again the sin and cos we have calculated in 17 and 18 question. So it will be again cos of a plus b. So cos A cos B minus sin A sin B. So it will be cos A cos B minus, again here it will be bracket, okay, minus sin A sin B, sin A is alpha, okay, cos alpha cos beta minus sin alpha sin beta upon 1 plus, now cos, no need to bracket, put in bracket here because here it is plus. So it will be cos alpha cos beta minus sin alpha sin beta, okay. Now we have just calculated the values of this. This was the upon 2 was not there, but we have just calculated the value in question 17. Okay, so again we will calculate 1 minus cos alpha cos beta, that is 3 by 5, cos beta is 5 by 13. Now minus minus will get plus, so it will be sin alpha sin beta means 4 by 5 into 12 by 13. So upon 1 plus, again cos alpha cos beta, so it will be 3 by 5 into 5 by 13 plus 4 by 5 into 12 by 13, okay. Now again by solving 5 will get cancelled, it will be 1 minus 3 by 13 plus 48 by 65 upon 1 plus, now 5 again will get cancelled, it will be 3 by 13 plus 48 by 65, okay. So if I take LCM will be 65 again, it will be 65 minus 15 plus 48 upon 65 upon, again LCM is 65, so it will be 65 plus 15 plus 48 upon 65, okay. 65 will get cancelled and 65 minus 15 is 50 plus 48, that is 98 upon, now again 65 plus 15 is 80 plus here it was minus sin A sin B, so here it is minus, okay. So 65 plus 15 is 80 minus 48 is 32, okay. Here it was minus, I mistakenly wrote plus, okay, because cos A cos B minus sin A sin B, okay. So it will be, if I divide it by 2, so it will be 49 upon 16, okay. So our answer is second one, that is tan square alpha plus beta by 2, we got 49 by 16, okay. There is also one easy method, it is too much lengthy method. We have just calculated sin square alpha by alpha plus beta by 2 and cos square alpha plus beta by 2. So sin upon cos is tan, so we can write tan square alpha plus beta by 2 as, this is our second method, I am telling second method, okay. So we can write tan as sin upon cos, so it will be sin square alpha plus beta by 2 upon cos square alpha plus beta by 2, okay. So it will be, what was our sin square alpha plus beta by 2? It was 49 by 65. Direct I am putting the values, and cos square alpha plus beta by 2 was 16 by 65. We have just calculated in question 17 and 18, okay. So Sine upon cos is tan. So I am writing sin square alpha plus beta by 2 upon cos square alpha plus beta by 2. Values were 49 by 65 and 16 by 65. I am taking these values from question 17 and 18. Okay. So 65 and 65 will get cancelled and our answer will be 49 by 16. It is a very short method. That was very long method. Okay. So 49 by 16, that is second option for question 19. Okay. Now question 20. Question 20 is given as sec theta is equals to 1 by 4. Sec theta is equals to 1 by 4. It is given in mixed fraction. So it will be in proper fraction, it will be 4 1s are 4 plus 1, 5 by 5, 5 by 4. It is a improper fraction. So sec theta we have got 5 by 4. It was mixed fraction, we have converted in fraction. Okay. Now we have asked to calculate tan theta by 2. Okay. Now again, what was the formula for tan square theta by 2? It was 1 minus cos theta. Tan square theta by 2 was 1 minus cos theta upon 1 plus cos theta. Okay, that was the formula. Tan square theta by 2 equals to 1 minus cos theta upon 1 plus cos theta. So from that we can calculate. Now here it is cos, but cos is not given. Okay, so first we have to calculate cos. So cos theta is the ratio of, it is the inverse of what? It is the inverse of sec. So cos theta is 1 upon sec theta. Sec theta is given 5 by 4. So we just put in the value. Sec theta is 5 by 4. So it will be 4 by 5. Okay. From sec theta we have calculated cos theta as 4 by 5. Now we can put it in the formula. What is tan square theta by 2? Equals to 1 minus cos theta. I will directly write cos theta is 4 by 5 and 1 plus cos theta. Cos theta is again 4 by 5. So it is 1 minus 4 by 5, 1 plus 4 by 5. 1 minus cos theta upon 1 plus cos theta. So it will be, if I take LCM, it will be 5 minus 4, that is 1 by 5 upon 5. Again LCM is 5, 5 plus 4, that is 9 by 5. Okay. So, but this is the value of tan square theta by 2. Now 5 will get cancelled. Okay. So we have got 1 by 9, but it is the value of tan square theta by 2. So by taking square root on both sides, what we will get? We will get the value as 1 by plus minus 1 by root 3. Okay, we are taking square root. So it will be 1 by 3. Square root of 9 is 3. Okay. So tan square theta by 2 we have got 1 by 9 and tan theta by 2 1 by 3. So it will be our first option, that is 1 by 3 of question 20. Okay. We have just used that formula tan square theta by 2 equals to 1 minus cos theta upon 1 plus cos theta, and just put in the value of cos theta. From sec theta we have calculated cos theta, and just putting in the values we have calculated tan theta by 2. Okay. Now question 21, the quadratic equation whose roots are, we have to find the which quadratic equation is that whose roots are sin 18 and cos 36. Okay. So roots are given as sin 18 and cos 36. Okay, and we have to find which quadratic equation have that roots. So, okay, one condition is there. If alpha and beta are roots, if alpha and beta are roots of quadratic equation, then quadratic equation is given by, x square minus alpha plus beta into x plus alpha beta is equals to 0. Okay. Now, if alpha and beta are roots of quadratic equation, then quadratic equation is given by x square minus alpha plus beta into x plus alpha beta equals to 0. This is the condition. Okay. If I consider this as alpha and cos 36 as beta, okay, I am considering alpha as sin 18 degree and beta as cos 36 degree. Okay. So, our equation will be formed as x square minus, equation will be in this form. I will write it again, x square minus alpha plus beta into x plus alpha beta equals to 0. Okay. Now, I will just put in the values of alpha and beta. I have taken alpha as sin 18 and beta as cos 36. If these are the two roots of the equation, then this will be our quadratic equation. So, it will be x square minus alpha is sin 18. So, I will just put in the value sin 18 plus beta is cos 36 into x plus alpha beta, means there is multiplication of sin 18 and cos 36. It is equals to 0. Now, do you remember we have just written the values in the first lecture of sin 18 cos 36? We have written the value of sin 18 as, it is the fixed value. If you learn it, it will be suitable for you to solve the examples. Okay. Sin 18 is root 5 minus 1 by 4 and cos 36 is root 5 plus 1 by 4. Just learn these values. Okay. Sin 18 is root 5 minus 1 by 4 and cos 36 is root 5 plus 1 by 4. Okay. So, I will just put in the values of sin 18 and cos 36 in this. Okay. So, it will be x square minus, now sin 18 is root 5 minus 1 by 4 plus cos 36 is root 5 plus 1 by 4. Now, plus again sin 18 cos 36, but here it is multiplication. So, it will be root 5 minus 1 by 4 multiply by root 5 plus 1 by 4. Now, if I further solve this, it is equals to 0. So, if I further solve this, it will be x square minus, now denominators are same. So, we can directly add this. So, it will be, we can directly add numerators. So, it will be root 5 minus 1 plus root 5 plus 1 upon 4. Okay. I have added the numerators because denominators are same and denominator will be 4 as it is. Now, plus here it is, you can see here it is root 5 minus 1, root 5 plus 1. If I take it as a, it has 1 as b. So, it is a minus b, a plus b. So, formula for a plus b, a minus b is a square minus b square is equals to a plus b, a minus b. So, here it is a minus b, a plus b. So, if I take it as a, this as b, so it will be a square minus b square. So, a square is root 5 square minus b is 1, that is minus 1 square upon, and denominators will be multiplied, 4 multiplied by 4 is 16 equals to 0. Now again by solving x square minus, now here it is minus 1 plus 1 will get cancelled, and root 5 plus root 5 is 2 root 5, here it is x, 2 root 5 upon 4 into x plus, now root 5 square is 5, 5 minus 1 is 4, so it will be 4 upon 16 equals to 0. Now 2 and 4, it can be divided by 2, 2 ones are 2, 2 twos are 4, so it will be x square minus root 5 upon 2 plus, if I divide it by 4, in numerator and denominator it will be 4 ones are 4, 4 fours are 16, so plus 1 by 4, it is equals to 0. Now we want quadratic equation not in the form of this. If I take the LCM of 2, 4 and 1, it will be 4. So what we can get, 4x square minus 2 root 5, here it is x, 2 root 5x plus 1, it is equals to 0. So we have got the quadratic equation as 4x square minus 2 root 5x plus 1 equals to 0. So our option is third one, that is 4x square minus 2 root 5x plus 1 equals to 0. Okay. We have just taken alpha and beta as sin 18 and cos 36. Alpha is taken as sin 18 and beta is given as taken as cos 36, and we have just applied according to the condition. If alpha and beta are the roots of the quadratic equation, then quadratic equation will be x square minus alpha plus beta into x plus alpha beta equals to 0. Okay. I have just applied the condition and put in the values. Just learn the values, so it will be easy for you to solve the examples. Okay. Now question 22. Question 22 is sin 2a sin 2a upon 1 plus cos 2a. And again 1 cos a upon 1 plus cos a. Okay. This example is given and we have to find the value of this. Now here it is sin 2a. Do you remember the formula for sin 2a? It was sin 2a was 2 sin a into cos a. Okay. Sin 2a 2 equals to 2 sin a cos a. We can put the value sin 2a as 2 sin a into cos a. Now 1 plus cos 2a. So it was the formula for cos square a. So if I take cos square a, it was 1 plus cos 2a upon 2. Okay. That was the formula. Okay. Cos square a equals to 1 plus cos 2a upon 2. So here it is 1 plus cos 2a. So from this we can calculate the value of 1 plus cos 2a. So it will be 1 plus cos 2a will be 2 into cos square a. Okay. From this formula we have calculated 1 plus cos 2a. So we can directly put in the value. Sin 2a was 2 sin a cos a, 2 sin a cos a upon, and 1 plus cos 2a we have calculated from this cos square a. 1 plus cos 2a, that is 2 cos square a. Again second bracket we take as it is cos a upon 1 plus cos a. So now 2 will get cancelled, and cos A, here it is cos A, here it is in multiplication, so it will be cos A into cos A, that is cos square A, so it will be cancelled with cos square A in denominator. So what is remaining? Sin A upon 1 plus cos A, sin A upon 1 plus cos A. Okay, we have just used that formulas and replace it, sin 2A by 2 sin A cos A and 1 plus cos 2A by 2 cos square A, and second bracket we write as it is, and cos square A is cancelled and 2 is also cancelled. So remaining is sin A upon 1 plus cos A. Now sin A, so sin 2A was, from this we can calculate sin A, angle is half, here it was 2A, here it is A. So we can make the formula of sin A from this. So it will be, angle is halved, so we will also take the half of this A by 2. So it will be 2 sin A by 2 cos A by 2. Okay, we can also learn it, or you can calculate from this. Here angle was double, we have halved, so angle of right hand side will also be halved. So it is 2 sin A by 2 cos A by 2. Okay, so sin A will be 2 sin A by 2 into cos A by 2. Again, here it is 1 plus cos A. So from this we can calculate 1 plus cos A. So here it was, angle was doubled. So if I halve the angle, this formula was taken from this, and if I 1 plus cos A, 1 plus cos A, we want here 1 plus cos A, okay, that was 2A, angle was doubled, here it is halved. So right hand side angle will also be halved. So it will be 2 cos square A by 2, okay. So 1 plus cos A is equals to 2 cos square A by 2, okay. 1 plus cos A, 2 cos square A by 2. Now 2 and 2 will get cancelled, and 1 cos A by 2 and cos A by 2 will get cancelled, and what is remaining? Sin A by 2 upon cos A by 2. Okay, remaining is sin A by 2 and cos A upon cos A by 2, and what is sin upon cos? It is tan. So it will be tan A by 2. So our answer is tan A by 2. Second option, okay. Option number second, for question 22 option is second, that is tan A by 2. Now question 23, matrix match type. Now sin alpha is given as 3 by 5. And alpha is in between 90 and 180. Okay, alpha is in between 90 and 180, means it is in second quadrant. Okay, alpha is in second quadrant because it is in between 90 and 180. So alpha is in second quadrant, so we have to solve according to second quadrant. So we have to calculate cos alpha by alpha for this question, okay, for solving all the matrix match types. So if I take a triangle, right angle triangle, and this is your angle alpha. So sin alpha is, ratio for sin is opposite upon hypotenuse, and alpha is given as, sin alpha is given as 3 by 5. So opposite side of alpha is 3 and hypotenuse is given as 5. So by Pythagoras theorem it will be 5 square minus under root of 5 square, that is 25, minus 3 square, that is 9. So it will be root 16. So it will be 4. Okay. So this side will be 4. So we can calculate, we have got this side as 4, so we can calculate cos alpha. So cos alpha will be, cos alpha is adjacent upon hypotenuse. So adjacent side of alpha is 4 and hypotenuse is 5. So we have got cos alpha as 5, but condition is given that it is in second quadrant. It is not just given for for fun, okay? It is given to apply the condition. It is in second quadrant. So in second quadrant cos is negative, so it will be negative, okay? This is very important because it is in second quadrant, cos is negative in second quadrant. So our answer will be not 4 by 5, it will be minus 4 by 5, okay? So cos alpha we have got as minus 4 by 5 because since it is in second quadrant. Now sin alpha by 2. We have to calculate sin alpha by 2. So do you remember the formula for sin square alpha by 2? It was minus cos alpha by 2, okay? Sin square alpha by 2 is 1 minus cos alpha by 2, it is the formula. So we can apply here the formula for calculating sin alpha by 2. So it will be sin square alpha by 2 is equals to 1 minus cos alpha by 2, okay? Just put in the value of cos alpha, it is minus 4 by 5. So it will be minus of minus 4 by 5 upon 2. So it will be 1 plus 4 by 5 upon 2. So it will be LCM is taken as 5. So it will be 9 upon 5 and denominator will get mixed. So it will be 9 upon 10. Okay. But this is the value of sin square alpha by 2. But we want sin alpha by 2. So taking square root on both sides, it will be sin alpha by 2 equals to plus minus 3 upon under root of 10. Okay. 9 is the square of 3. So under root of 9 will be 3. 3 upon under root of 10. So your answers are given in 1 by root 10. 3 by root 10. Okay. Only positive answers are given. So it will be 3 by root 10. Sin alpha by 2, that is for A option, for A question answer is R, that is 3 by root 10. Okay. Now second is B is cos alpha by 2. We have to find cos alpha by 2. Okay. Do you remember the formula for cos square alpha by 2? Formula for cos square alpha by 2 was 1 plus cos alpha upon 2. Okay. So we can just put in the formula here and calculate cos alpha by 2. So it is cos square alpha by 2 equals to 1 plus cos alpha upon 2. So it will be 1 plus cos alpha is minus 4 by 5 upon 2. So it will be LCM is taken as 5, 5 minus 4 is 1, 1 upon 5 denominator and it will mix with this denominator, so it will be 5 into 2. So it will be 1 upon 10, but this is the value of cos square alpha by 2, cos square alpha by 2, okay. So if I take the square root on both sides, so it will be cos alpha by 2 and 1 upon under root of 10, okay. So cos alpha by 2 is calculated as 1 upon root 10. That is the S option. For B, that is option is S, okay. Now next is tan alpha by 2. Now tan alpha by 2, we have just calculated sin alpha by 2 and cos alpha by 2. So tan is the ratio of sin upon cos, that is sin alpha by 2 upon cos alpha by 2. Okay, we have just calculated the value of sin alpha by 2 and cos alpha by 2 in A and B. So we can directly put in the value. So sin alpha by 2 we have got as 3 by root 10 upon cos alpha by 2. Cos alpha by 2 was 1 by root 10. We have calculated just in question matrix match B. Okay. So it will be root 10 and root 10 will get cancelled and it will be 3. So tan alpha by 2 we have got as 3. Okay. Now it can be solved by another method also. If tan square alpha by 2, formula for tan square alpha by 2 is 1 minus cos alpha upon 1 plus cos alpha. Okay. You can also solve by this method, tan square alpha by 2 equals to 1 minus cos alpha upon 1 plus cos alpha, and put in the value of cos alpha here, and you can also solve by this formula also. Okay. So tan alpha by 2 is 3, that is option Q. Tan alpha by 2 is equals to 3 is option Q. Okay. Now cot alpha by 2. Now cot is the inverse of tan. We can write cot alpha by 2 as 1 upon tan alpha by 2. It is the inverse of cot. Tan is the inverse of cot and cot is the inverse of tan. So cot alpha by 2 can be written as 1 upon tan alpha by 2, and we have just calculated the value of tan alpha by 2 in C. What was that? It was 3. So value of tan alpha by 2 we have just calculated as 3. So it will be 1 upon 3. We have cot alpha by 2 is equals to 1 upon 3. So it is the option P. Okay. You can also solve this by cot square alpha by 2. Tan square alpha by 2 was 1 plus cos A upon 1 minus cos A. 1 minus cos A upon 1 plus cos A. So cot square alpha by 2 will be 1 plus cos A, here it is alpha, upon 1 minus cos alpha. You can also solve by this formula, cot square alpha by 2 equals to 1 plus cos alpha upon 1 minus cos alpha. You can just put in the value of cos alpha and you can calculate. Okay. You can solve by this method also and by this formula also. Okay. Now cot alpha by 2 we have got as 1 by 3. Okay. Now question 24. Question 24 is cos 18 sin 36 equals to root 5 by k, and we have to calculate the value of k. Okay. Again it is very easy. You have to just put in the value of cos 18 and sin 36. We have written in the formulas the values of this. Okay. Just go and check down the videos. Okay. So cos 18 is under root of 10 plus 2 root 5 upon 4. Under root of 10 plus 2 root 5 upon 4. Okay. Cos 18 value is that one, and sin 36 is under root of 10 minus 2 root 5 upon 4. Okay. Cos 18 sin 36. We have written the values in the formula. Go and check the videos. Okay. Now you have to just put in the value of sin 18 and cos 18 and sin 36. So it was under root of 10 plus 2 root 5 upon 4 into sin 36 is under root of 10 minus 2 root 5 upon 4. So it is equals to root 5 by k. We have just put in the value of cos 18 and sin 36. So it is. Now see, here it is a plus b. If you see this, if you take 10 as a and 2 root 5 as b, it is the formula of a plus b, a minus b. Okay. The formula for a minus b, a plus b is A plus b, a minus b is a square minus b square. Okay. So, square root we will write as it is because there was no square root. So, we will take the square root as it is and we will just take the 10 and 2 root 5 as a and b, a plus b, a minus b. So, it is a square minus b square. So, it will be 10 square minus 2 root 5 square, okay, upon, now 4 4s are 16, it is equals to root 5 by k. Now, further solving, 10 square is 100 minus, now 2 square is 4 and under root of 5 square is 5. So, 5 4s are 20. So, it is upon 16 is equals to root 5 by k. Now, it is 100 minus 20 is under root of 80 upon 16 equals to root 5 by k. Now, under root of 80, we can write under root of 80 as 16 5s, okay, we can write 80 as 16 5s upon 16 equals to root 5 by k. Now, if we take out the 16 outside the square root, so it will be 4, okay, under root of 16 is 4, so it will be 4 root 5 upon 16 equals to root 5 by k. So, 4 1s are 4, 4 4s are 16. So, what is remaining? Root 5 by 4 equals to root 5 by k. So, k will be equals to 4. We got the answer, k is equals to 4. We have just put in the values of cos 18 and sin 36. If you know these values, you can easily solve this sum, okay. Just remember the values. So, k is equals to 4 for question 24, okay. Now, the last question is, again quadratic equation is given. Quadratic equation is given as x square minus 2 root 2 x plus k equals to 0. Now, and roots are given as, roots are tan 22.5 degrees and second root is given as cot 22.5 degree, correct? Yeah, correct. And we have to find the value of k, okay. Now, quadratic equation is given x square minus 2 root 2 x plus k equals to 0. And roots are tan 22.5 degrees, cos 22.5 degrees. So, we have just taken the question, that was if alpha and beta are roots of the quadratic equation, then what was the quadratic equation? This is x square minus alpha plus beta into x. I write it again, if alpha and beta are roots of quadratic equation, then quadratic equation is x square minus alpha plus beta into x, okay, plus alpha beta, it is equals to 0, okay. If alpha and beta are roots of quadratic equation, then quadratic equation is x square minus alpha plus beta into x plus alpha beta equals to 0. So, this is in this form, okay, x square minus alpha plus beta, if we take 2 root 2 as alpha plus beta into x plus alpha into beta is k. If we compare these two equations, I put it as equation 1 and this as equation 2. This is the condition you should always remember. So, if I compare these two equations, if I compare equation 1 and equation 2, we have to calculate k. If I compare this 1 and 2, k will be equals to alpha beta. So, k will be equals to alpha beta. I compare both the equations. So, k will be equals to Then alpha and beta are this one, alpha beta are roots. So, alpha I take tan 22.5 degree as alpha and cot 22.5 degree as beta. So, it will be alpha is tan 22.5 degree and beta is cot 22.5 degree. So, again we can write cot is the inverse of tan, we can write cot as 1 upon tan. So, it will be tan 22.5 degrees, cot is 1 upon tan, 1 upon tan 22.5 degrees. So, tan 22.5 and tan 22.5 will get cancelled and we will get k as equals to 1. Okay. Now, question 25 answer is k is equals to 1. So, now we have completed worksheet 3. Okay. In the next lecture we will start with worksheet 4. Okay. See the videos. Bye.